So looking at vector operations here, A plus B. Number one, I'm pretty sure that's your resultant. I'll call it vector capital R for resultant, or you could call it A. I don't know, whatever. Correct? Yes? Moving straight across to number 6. Number 6 is B plus A, and you'll notice you get a similar looking thing to number 1. And what we said, Callum, was with vectors, the order you add stuff in doesn't matter. What's 5 plus 6, Callum? What's 6 plus 5? Also 11. What's A plus B? The same as B plus A. Subtracting, though, is different. What's 5 take away 6? What's 6 take away 5? Positive 1. Subtracting the order matters. You may get the same magnitude, but you'll be pointing in the wrong direction, as was evidenced by the negative there. C plus B and B. So C plus B is going to look like this. C plus B. Oh, that's a terrible drawing, Mr. Dueck. You need more room. C plus B. I think number 2, you get something like that, yes? And when you go B plus C, you also get something. Oh, change the colors, Mr. Dueck. You also get something like that. The same. Number 2 and number 7 should look identical. Your resultant should look identical. Number 3, A plus C to the right and then sideways. Gotcha. A plus C. That would be your resultant. Probably using the sine law or the cosine law or components if I'm going to solve that. A plus B plus C. So I went like this. A plus B plus C. I kind of get almost a 2C, almost twice as long as C is what it looks like. A minus B, I don't. That's going to be A plus negative B. That's going to be A, still pointing to the right. B was down, so negative B is going to be pointing up. There is going to be a subtraction question in your future somewhere in an assessment. That's number 4. Yes? 2A. 1A. 2A. Kind of like that. Ish. Number 5. B minus A. Nuh-uh. That's the same as B plus negative A. B plus negative A. Where are you going to use that the most? You're going to use that this year when you're doing a change in, because what's change in anything? Did you say minus? That's going to be a subtracted vector. So if they say find the change in acceleration, the change in velocity, or the change in momentum, and they're not in a nice straight line with each other, you're going to have to do a little bit of vector mathematics. Number 10. Why did I write that? Why did I write 0? Well, I think vectorially, Josh, first of all, it's going to be plus negative, yes? I think you get this. A, B. Now, normally C would be this way, but because it's plus negative, C is going to be that way. Oh, I think I end up back where I started from. And if you end up back where you started from as a vector, Nate, what does that mean? The total ended up being 0. Very similar to that big football play at the end of your notes. If you did bother to run it out, you would find that the vector sum of all those rights and lefts does add to 0. Okay? Thumbs up. I'm not going to collect that. That was purely for practice. If you did do it, yay, you got better at it. I'm hoping it only took you about 5 minutes or so. So, continuing on. Applications of vectors. Who had me for Physics 11 last year? Yeah, same lesson, change the numbers and tweaked it a bit. If you're really paying attention to the vector lesson that I did last year in Physics 11. The famous river question. A river or an airplane in a boat in a river or an airplane in a crosswind are 2 great examples of vectors. 2 great examples of situations where you can add speeds together to get a different answer. And I got a couple of videos to show you. My Physics 11 kids saw them last year, but they're pretty cool anyhow. So here's the first one. An observer is standing on the shore of a river. Check. He sees a boat traveling across the river. While the boat's engine is pointing the boat directly across the river, the current is pushing the boat sideways. And the boat's velocity with respect to the shore is 8 meters per second at an angle of 65 degrees with the shore. What does DULP stand for? Let's draw a little picture. So I'm going to go, because my drawing sucks, I'm going to go draw, line. There's one side of the river. Draw, line. There's my river. I could draw it vertically, but I think there's more room to draw it nicely horizontally, and it's a good diagram always helps. I left room there. Let's all decide. The question doesn't say, but just so we're consistent, how about we all let the current point to the right? So I'm going to say this. An arrow pointing like that, and I'll call that VC for V current. So let's visualize the boat. Which way is the boat pointing? What does the question say? Bree, what did that pen pointing straight up into the air imply? Straight up. So you know what? I'm going to draw an arrow like this, and I'm going to call that, what does the E stand for? Engine. And then I think the current would be pushing it sideways like that. That there is the resultant. And I know that's what this question gave me. That's what makes this a little bit more difficult than Physics 11. In Physics 11, I probably would have given you the components. Here, I'm actually giving you what the observer saw. Michael, how fast did the observer see the boat traveling at?
8 meters per second.
That's this one. At what angle?
65.
Where am I going to put that? With respect to what?
This short.
Okay, so that angle there is 65 degrees. That doesn't help me much. Or does it? Now, those of you that were in Pre-Calc 11 last year, do you guys do any geometry in there? Angles on a line, supplement, any of that stuff? Does that ring a bell? You're looking blank? Okay, so I'm going to teach you a very, very handy trick. It's called alternate interior angles, although most people just call it the Z rule. It looks like this. Don't write this down. See the big Z? Okay. Or, Curtis, it also works if the Z is backwards. As long as the top and bottom of the Z are parallel to each other, so that your Z does not look like this, which is technically a Z, but the top and bottom aren't parallel to each other. As long as the top and bottom are parallel to each other, that angle and that angle, the interior angles are the same. And there's a lovely proof. But here's what I'm saying. Here's the point. Pick your pencils up. Oh, don't want to erase that, Mr. Dueck. See that 65? That there is 65. Mr. Dueck! Yes, Elijah. Look, I knew that this forms a right angle, and I just went 90 minus 65, and I said, hey, that's 25. And I'm totally fine with that. What I'm going to do all year long, Kelly, just so all of our work looks the same, is whenever I can find the actual size of the angle that they gave me in the diagram, I'll try and find that angle in the diagram. So if you're wondering, if you're looking at my notes, William, if you're looking at one of my answer keys, saying, what did you do? That will always be my approach. And I will give you full marks, William, if you said, hey, that's 25. Your trig functions will all be different from my trig functions. In fact, wherever I use sine, you'll use cosine. Wherever I use cosine, you'll use sine. Sine. Sine and cosine are kind of opposites of each other. Okay? No, tangent is the weird one. It's the ugly cousin. It doesn't quite fit in. So, I've got my diagram set up. Let's do some physics. Mickey, what's A asking me to find? in my triangle, it looks to me like this is the hypotenuse. The current is, I think, adjacent, yes? Now, again, if if you're using the bottom left one, you'd be not calling the current adjacent, you'd be calling it opposite, but you'd also be using a different angle. Mickey, which trig function can I use if it has an A and an H in it? Too slow. You know what we need to do? Since you had to think about it, probably you should have done this somewhere at the top of your page and cut down on your thinking. Which trig function? Did you say cosine? You would be right. What always goes next to the trig function, my friend? The angle. What's the angle this time? Yep. Equals adjacent over 8. Mickey's eyes just light up because he's realized once again this is 1 fraction equals 1 fraction. That 8 we could just move diagonally across. This is cross multiplying. It's technically cross multiplying, but we're not even doing the multiplying and dividing part. We're just saying we know what the final answer will be. It's cross multiplying with a vengeance. So if I hear you, Mickey, you're saying the current is going to be 8 times the cos of 65, which is what? Do y'all get 3.38? Yeah? Meters per second. Hey, you know what? Let's do compass rose right here. And let's add a direction. What do we call that? Based on our map, I didn't give you directions in the original question, but if I'd given you the diagram, based on our map, we could also then say due east. Due east. Harjot, what's B want me to find? What's that in my diagram? VE, okay. Harjot, you could use VC, the current, to find VE, but just in case I got current wrong, I'm a good test writer. I always tend to hedge my bets. I'm going to call this opposite. Which trig function would you recommend, my angel? Did you say sine? Good. You didn't say sin, though, did you? Because saying sin would be a sin, right? Sine? Okay. Of 65 equals, and I think it's going to be that. By the way, don't write this down, but I said if you used the 25 in the bottom left, you'd have a sign there. You may notice 8 sine 25 gives you exactly the same answer, William, 3.3809. That's why sine and cosine are complements of each other. The sine of, for example, 30 is the cosine of 60. The sine of 20 is the cosine of 70. This one is going to be 8 sine 65. Do you get 7.25? Meters per second north. Okay. Now, to keep this question simple, we'll do bad physics. Let's pretend that is gunning the engine as fast as is possible, and the person running the boat's going to keep it like that. The acronym for that is WOT, stands for wide open throttle. So I don't want to changing engine speed right now, at least at this stage. So they're just flooring it, and that's what they're doing. Okay, for the remainder of the next few questions. If the river is 256 meters wide, how long does it take to cross the river? Claire, what's this one asking me to find when it says how long does it take to cross the river? Did you say time? Good, let's write down T equals question mark. What else, Claire, what else did this question give me? Which distance? Let's go back to my diagram. And, oh, did I lose my upper line somehow there too? Good gosh, Dueck. Black, draw. Sorry, I lost half my river. Don't go anywhere. Sorry, say it again, kiddo. I'm going to draw it in like this. Claire, do you notice that that distance is a north-south distance on my map? Here's the key. To solve this, don't you dare use anything but a north-south velocity. In other words, don't you dare use the current, that's not north-south. Don't you dare use this slanty one, that ain't north-south. You know which velocity I'm going to have to use? Engine velocity, which is why I had to walk through those first couple of steps before I could ask you part C. So I know that my distance, whoop, change colors, Mr. Dueck. I know that my distance is 256. Which speed am I going to use, Claire? Which was what? Okay. This is why I made this statement earlier. What did I say the acceleration was going to be? If he just keeps it at wide open throttle, what's the acceleration going to be?
Zero.
Zero. This is, otherwise, kids are, what's the acceleration? I'm saying, let's pretend there is none. Constant speed, okay? Hey, what equation can I go with here that has got a T, a D, a V, and an A? I think you actually just end up with this, don't you? It's plus a half AT squared, but what's A? Zero. So I think Claire, that whole thing would, you just have that, yeah? Just, yes?
Yeah.
Get the T by itself, Angel.
Oh.
Is that what you said?
Yeah.
If it wasn't, pretend you did. So it's going to be 256. I'm going to write 7.25, but I think I have this number still stored. I got this still stored on my calculator. I'm going to use my answer button. And I get 33.3 seconds to get across. 35.3 seconds to get across. Thank you. Can't read. Ashley, what does D want me to find?
How far?
Distance, right? Keep reading. How far?
Down the lane for the boat from the point it reaches the far side.
Let's put that in my diagram. Where am I going to put that? I think what we're talking about here, Ashley, is this distance. In fact, you know what? If I really wanted to, I could call this vertical distance in my diagram, and I could call this horizontal distance in my diagram. Yeah? Ashley, what direction is that horizontal distance in? East and west. What velocity had I better use if I'm going to analyze a horizontal distance? A velocity that it's in what direction? So am I going to use VR equals 8? Am I going to use VE, which is 7.25? Are you saying I'm going to use the current? You would be correct. So let's write that down here now. V current, which was 3.38. And you already told me, Ashley, they want me to find that. That's not enough. Oh, wait. I know one more thing. Do you see it? Ah! That's why I had to do part C first. I had to calculate time first. The time to go up is going to be the same amount of time that you're going to drift sideways. So the time is going to be 35.3 seconds. And Ashley, what did we say the acceleration was? I'm looking for an equation that has v, d, and t. You know what? I think it's going to be exactly the same as the one above, only this time we don't need to get the stinking t by itself because the d is already by itself. This is going to be straight plug and chug. It's going to be 3.38 times 35.3 3.38 times, oh, I have 35.3 stored on my calculator. I'm going to go second function answer because that's less typing and more accurate. Do you get 119.34, 2 or 3 sig figs, 119 meters. So for a boat, engine velocity plus current velocity gives you resultant velocity. Oh, and for a plane, engine velocity plus wind velocity gives you resultant or ground velocity. Technically, they call it ground speed in slang, but they do mean ground velocity. They say, what's your airspeed? What's your ground speed? But they really do mean velocity. Suppose you want the boat to travel directly across to land directly across from its starting point. Well, how can I do that? I think what that means is I'm going to have to take this boat and instead of going straight across, I'm going to have to slightly point it into the current to exactly cancel out the sideways push. Yeah? Yeah. So, suppose this is going to be popping up like crazy. I'm sharing files with another teacher from my Dropbox, so just ignore that. Several thousand files. Suppose you want the boat to land. Well, what direction should I point it? You know what? I'm going to redulp since I've kind of moved a page over, and I'm going to say to myself, well, here's my river. I'm going to point the boat, the engine, that way. Remember, we're saying this. Engine plus current is relative to the shore. Engine plus current relative to the shore. So I want to add engine plus current. Hey, how do I add those two vectors together? Draw them tip to tail. Now, put your pencils down, look up. I'm going to start drawing the current. How do I know not to go that far with the current? Or, how do I know not to only go that far with the current? Tell me when to stop drawing. Right there? Back a bit? How do you know, Aaron? Well, here's what it says. I know the resultant. The resultant is supposed to be in a straight line up. So even though I don't know how big the resultant is, I know what it's supposed to look like. It's supposed to be slanty plus current gives me straight up. Now the engine, we said we're going to keep at a constant wide open throttle speed. So what did we say the engine speed was from the previous question? I think it was B. What was the engine speed from the previous page? I've scrolled down. 7 point, I missed that? 7.25? And what was the current? Alex?
3.38.
Now this is going to be the resultant velocity. By the way, you'll notice I didn't ask you for the direction of the resultant velocity. That I already know. North! But I want to find the magnitude. But it wants the direction that I should point the boat. So let's divide this into a part A and a part B. What direction should I point the boat? Well, I think I would point the boat that way. Is that okay? Of course, that's not in my triangle. But Jordan, my friend, see the Z? So Jordan, my friend, I think I can also say that angle right there is the same side. That's the magnitude of the angle I'm trying to find.
Wouldn't you just do the opposite of the v relative of the first question? Because
Why didn't I just do the what?
the opposite of
The
v
complement of the first question?
Yeah, because you're going this, right?
I think you're going to find it actually doesn't work. Just can't hang on. It's a great suggestion, and we'll come back in a second. Hey, VC, opposite, adjacent, or hypotenuse?
Opposite.
Adjacent, 7.25. V engine, hypotenuse. Hey, to find an angle for the first time all year, it's not tangent. To find an angle this time, what trig function is it?
Cosine.
It's not always going to be, it's going to mostly be tangent, usually be tangent, not always be tangent. Cosine of theta equals 3.38 all over. See, Cliff, I think you'll be right if we get an answer of 65 degrees or 25 degrees, like in the previous situation. I don't think we're gonna. What do you get for theta? No answer. 3.38 divided by 7.25, and yeah, I didn't get 65. Close, but I didn't get 65. 62.2, is it 62.2? At, how could I describe this angle right here? North of south, east of west, what of what? How can I describe that angle right there? North of south, east of west, what of what? North of west would be right. That's which way I want to point the boat. I want to point the boat into the current at an angle of 62.2 degrees off the shore. There's another way you could have described it, but I went with north of west because we did draw compass rose earlier. Yes? Is that okay, Mike? Good, Michael? B says, what's the resultant vertical velocity? So now it wants me to find VR. How can I find VR? Is there a right angle? Then I can Pythagoras. Only this time, not finding a hypotenuse either. This time my equation is going to be VR squared plus 3.38 squared equals 7.25 squared. Right? Hakeem, how would I get the VR squared by itself? So 7.25 squared minus 3.38 squared. Oh, is VR 41.1381? Oh, what do I have to do now? Square root. 6.41? So, if I want to end up straight across from where I started from, I point my boat into the current, and I travel at 6.41 meters per second with respect to the shore, even though my engine is still pushing me through the water at 7.25 at wide open throttle. Is that okay? Then I wrote down here, handy hint number 1. I flogged this last year. I think Mr. Kamosi did too. Change in anything is always final minus initial. This is really going to come in handy when you're subtracting vectors because it's also final plus negative initial. So there's V equals V final, delta V equals V final minus V initial, delta A equals A final minus A initial, etc., 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 etc. Handy hint number 2. Claire, as we pointed out, If they give you a vertical distance, you better use Vy to find t. If they give you a horizontal distance, you better use dx. In other words, please make sure in the river question and in the airplane question that your displacements and your velocities are lined up with each other. Don't you dare use a vertical displacement to find a horizontal, or worse yet, a slanty velocity. Shorter lesson today. I wrote down here, assign questions from Ultimate Kinematics Review. Give me a second and I'll look up which ones I'm going to assign. So just a little reminder, the Ultimate Kinematics Review was this big thing here. Right, looked like that. See if you got a copy. It's also online. Which ones are you now capable of doing? Well, let's shrink this down a little bit, Mr. D. Come on. You can do number 1. Four. Six. 8. 11. 13. 15. 17. 19. 20. 21. 24. 30. And then take a look at number 33 for a second. If you have the sheet in front of you, you may notice that on each of these reviews that I'll be giving you, the last few questions will be labeled scholarship section or scholarship questions. We used to have scholarship exams. These were nasty, wasty exams that people would try and they would write. You wrote a 2-hour provincial, then everybody else went home and you stuck around, you wrote a 1-hour scholarship exam. They were great questions because in my mind, Sam, they were good thinking, work your brain through, really figure stuff out kind of questions. So I've included a few of them at the end of each big review. You do not have to do these, but those of you that are shooting for like a 95 or higher, if you want, hey, if I can handle this, I'm in good shape, you can try the scholarship one. So 33 is a scholarship. You can't do it yet technically because it's a projectile, but in a few days when you're working on all of these, you can try it if you want to. 34, no. 35, no. A couple of videos to show you.